How to implement recursion. Yes friends, today we are going to discuss how to implement recursion. So let's begin. Hello everyone. Welcome to Programming Perception. I'm Amit Kumar and this is the 11th episode of Queries and Demands. Today we are going to discuss about how to implement recursion. So without wasting any time further, let's proceed with today's video. So before implementing recursion, let's see what is a recursion. Now recursion is actually calling of a function in itself. So if a function is calling itself in its own definition, then definitely we are doing recursion. Now there are two types of recursion. First one is direct recursion and second one is indirect recursion. Now direct recursion is the one which I told you when a function call itself. Indirect recursion is when a function is calling some other function which in return calling it back. So to keep the thing simple, I am talking about only direct recursion right now. So before I explain you and before I create any recursive function in the program, let me show you how a function actually executes. So to explain you the concept, I have created a program over here. Let me show you that program. So this is the program, episode 11.1. Now clearly you can see there are fun1, fun2 and main function over there. In fun1, fun2 and main, I have printed almost the same thing, except that in fun1 it is printing fun1 along with the message, in fun2 it is printing fun2 along with the message, and in main it is printing main along with the message, just to identify message is printing in which method. Now what I am doing here, the main will call the fun1 and the fun1 will call the fun2. So what I am doing here, in fun1 I am calling fun2 function and in main I am calling fun1 function. So you can see one more thing over here, that all these functions are static so that they can be called directly. Now if I will compile this, it will compile successfully. Whenever I will execute this program, it will start its execution from main. Now main will be the first function which is called. Once main is called, it will execute its statement and then fun1 is called. So before executing any statement further, main will take us to fun1. Now while executing fun1, it will print the first statement and then it will call fun2. Clearly fun1 will not execute the last statement because the function 2 is called here. So before executing this statement, it will call fun2 and the control will come to the fun2 function. It will print these two values and then fun2 function is over. So it will return back. Now where it will return? It will return back to the place from where it is called. That means here at fun2. And then it will print exiting fun1 and then fun1 is also over. So it will take us back to the place from where fun1 is called. Now this is the place and then it will print exiting main. Now clearly the first function to be called over here is the main and the last function to be called over here is fun2. Now the thing that is to be noticed here is the function which is being returned. So I'm calling main. Okay. And you can see the output. So here is a terminal window. Now clearly you can see entering main is printed. Then entering fun1 is printed. Now here in fun1 we have called fun2. So entering fun2 and exiting fun2. And then it will return back to fun1, then exiting fun1, and then it will return back to main, then exiting main. The point to be mentioned here is, in case of function calling, the last function which is called is the first function which is returned. And the first function which is called is the last function to be returned. In technical terms, function handling is dealt by a stack memory. Now we have not studied about data structure and we have not discussed about stack memory, so we will not go much in detail about it. But the thing that you should realize is, in function calling, the first function to be called is the last function to be returned. That's how function calling works. So now let's see how we can make recursion or how we can call a function in itself. So whenever we are performing recursion, we have to provide two things over there in the function. The first thing is recursive case And the second thing is returning case. Now, if you will miss recursive case, definitely function will not perform recursion. And if you will miss returning case, that means function will not return at all and it will become an infinite recursion. So let's see that. So here I've created another program, episode 11.2, in which I'm going to perform two things. First, print numbers. I will pass a number as parameter to this function. Like if I will pass 5, so this function will print from 5 till 1. Similarly, sum of natural numbers, I have to pass a number to it. Suppose I pass 5 to this method, then this method will add all the natural numbers from 1 to 5 and definitely it will return the result. Now because this function is only going to print, it's not going to return anything, the return type will be void. But this function is going to return something, so that's why I am keeping the return type as integer. Now let's perform one of the functions. So right now I'm keeping it void, otherwise it will show compile time error. Later on we will change that. And now I will call this print numbers function. So definitely I will create an object of this class. So obj is equals to new and the class name again. And now I will call this print numbers. So obj dot print numbers, and here I will pass a value x. Now I told you recursion is actually calling the function in itself. So if this function is calling itself inside its definition, definitely we are actually doing recursion. So first time I have passed a value, let's suppose I have passed 5. So definitely value of x will be 5. But the next time when this function will call itself, the value of x will change. So what I am doing, I am decrementing it. Okay, so the first time when this function is called, value of x will be 5. Next time when this function will call, value of x will be 4. So to show you that, I'm printing this value. I'm printing the value of x. So I hope that would be okay. Now compile and it's done. Now if I will run this program, this print numbers will print the number, but there will be an issue, and let me show you that. So I'm just running the main. Okay. And you can see it's also showing any exception. Now what was the reason why it's showing exception? Why it stopped abruptly? So let me show you that. Actually, this is the case where the function is keep on calling itself, right? And this is the case where stack overflow error occurs. Now keep that in mind. Stack overflow error occurs in case of infinite recursion. Now why infinite recursion is happening? The reason is very simple. We have actually created a recursive statement over here, but we have not given any returning statement. The statement after which this function will stop calling itself or recursion will stop. So to provide that case, I'm providing a condition over here. Okay, and condition is very simple. If x is equals to 0, then we will return. Now clearly this function is not returning anything, any type of value, it's void. That's why with this return statement, I'm not providing any value. So this is also valid. Now let me compile this and now let me run this again from 10 till 1, and here's the output. So clearly you can understand this recursion here. There are two statements which is actually performing or which is actually making the recursion possible. The first statement, which is this one, this is the returning statement or returning condition. And here when I am calling the function again, this is the recursive function. Okay, so I hope you got how to create a recursion. Now recursion can be used in all those situations where you are using iteration. Now you might be wondering why we will use recursion if iteration is much easier than this. Actually, there are some real life scenarios in which repetition is occurring, but we cannot solve that situation with simple loop. So in all those situations, recursion is actually the savior. Right? I'm telling you one such situation, like a game is there, Tower of Hanoi. Now to solve that game, definitely looping cannot be used. Similarly, there is a binary search tree, and if we are traversing that tree, again, looping cannot resolve our issue. So there are some real life situations where repetition is occurring, but that situation cannot be resolved with iteration. Hence, recursion came into picture. Now let's see how we are going to print sum of natural numbers. Now here, definitely we are going to return something. Now x will be passed, and because we are working with natural number, the same returning statement I will keep here. So if x equals to 0. Now the thing is, this function is not void. This function is returning something, and it is returning an integer. So in case x is 0, I will return an integer from here, and the integer will be nothing else than 0. So in case if x is 0, I will return that. Else, in case this condition is false, now definitely I will perform recursion over here. Now how I will do that? I will return the x plus, here I will perform the recursion. So I am calling sum of natural numbers method, and I am passing x minus 1 right now. Now this method will return some value, and that value will come right over here. Now to explain how this function is working, I am showing you that on suppose MS Paint. So clearly you can see I have made one column and plenty of rows over here just to represent a stack memory. When I am calling this sum of natural numbers method, so let me show you that, and let me pass a value to it, suppose 4. Okay, so what will happen when I will call this sum of natural numbers method? This 4 value will be passed to x. So the x will hold 4, and then it will start executing the statement. So I will execute this statement inside this paint so that you can understand what is happening when. So first time when this function is called, the value of x that moment of time was 4. So this was the 4, and it was called in main. So just for our sake, I am writing down where it was called. So it was called in main. Now definitely x is not equals to 0. So this condition is false, and it will come to else part, and in else part, this statement is executed. Now clearly value of x is 4 right now. So 4 will be there, plus sum of natural numbers method will be called. So again a function call. So I'm just writing down sum to represent sum of natural numbers, and what I will pass now, x minus 1. So current value of x is 4. So x minus 1 will return 3. Now again a function call is made. So it will get back to the same function again, and now value of x is compared. Now current value of x is 3. Definitely this is false, and it will be executed one more time. So the new statement will be 3 plus sum of natural numbers with value 2. Fine. So again this function will be called. So again it will come here. This condition will again be false because right now x is 2. So it will execute this function one more time. So this will become 2 plus sum of 1. Now again this function is called, and this time x is still not 0. Hence again this function will be called, and this time it will be called by 1 plus sum 0. And now clearly you can see when this time this function will be called, this statement becomes true. Our returning statement becomes true. Hence this time it will not execute the recursive statement, and it will return 0. Where it will return? It will return 0 from where it has been called. So it has been called from here. So this whole part will turn out to be 0 now. Okay, so let me clear this part, or let me write it here. So it will become 1 plus 0. Definitely 1 plus 0 will be 1, and this is the statement which is being executed. So 1 plus 0 is going to be returned. So 1 plus 0 is also returning, and where it will return? From where it has been called. So 1 plus 0 is 1, and it will return right here. So it will become 2 plus 1. Now definitely this is the statement which is getting executed. So this is also being returned. So 2 plus 1, that is 3, will be returned here. So this will become 3 plus 3. So this is the statement which is getting executed. This is returning value, and this is the current instance. So current value is 3, returning value is also 3. So 3 plus 3 is 6, and that is also going to return. So here it will come as 4 plus 6. Now that will become 10, right? And 10 will be returned to the main. Actually, that is the place from where it has been called first. So the value of 10 will return right here, right? Okay, so clearly 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So sum of 4 natural number is 10. It is giving correct result. Now let's see how the program is working. So I hope this dry run makes recursion more clear to you. And now let's run this program and check the output. So the first output will be definitely printing numbers and the next output will be sum of natural numbers. But still there is a problem in this program. It will not give us the desired result. Let me run and show you. Okay. So clearly it is printing from 10 to 1, that is print numbers function, and that is working. But this sum of natural numbers is not working. Actually it is also working, but make sure that this method, this function is returning a value. So that returning value should be held somewhere, or you can directly print this value as well. So I'm printing after storing it in a variable. So here it is, and I'm also printing sum is equals to sum. Quite good. So let me compile this and finally let me execute the program. So clearly you can see it is working with print numbers and it is working with sum of natural numbers, and both the program we made here with recursion. So I hope recursion is more clear to you. It is not part of class 10th definitely. So in your higher classes, definitely you are going to use recursion a lot. So that's it in this episode. Hope to meet you in the next episode. Till then, thank you and happy programming.